So we have f of t, right, as a positional function depends on the moving. For a moving object, it depends on time. If the object is in the same place as two different instant t equals to a and t equals to b, then f of a equals to f of b. So Rolle's theorem says there must be some instant of time t equals c between a and b, and the derivative equals to 0. Or to say, the tangent line at c is a horizontal line. Or to see the velocity at the time t equals c is 0. Example 2, let's prove the equation x cubed plus x minus 1 equals 0 has exactly one real root. All right, we want to use or apply Rolle's theorem. This is saying intermediate value theorem. Let's go to intermediate value theorem 1.59. I don't want to go back there. Basically, that is to say, so how do we find a real root, right? If a function is continuous, here we see this. If we make this a function, we call f of x equals x cubed plus x minus 1. This is a polynomial, right? Degree 3 function. Of course, it's continuous on all real numbers. So the trick is we want to find f of a less than 0. Well, the y value is lower, is under x-axis. And we find b, and f of b is greater than 0, is above x-axis. Because the function is continuous, that's for intermediate value theorem, because intermediate value theorem does not need derivatives. If the function is continuous, at a certain point a, the function is negative, function value is negative. At another point, the function value is positive. It must go through the function equals to 0, right? The root is the function value is 0. That's the intermediate value theorem. If we want to apply intermediate value theorem, we say, okay, let's say f of 0, right? F of 0, find a. F of 0 equals -1, less than 0. And f of 1, 1 we think as b. F of 1 equals 1, which is greater than 0. So in between of 0 and 1, there must be a number c. We don't know what c exactly is yet, but there must be such number. And the derivative equals to 0. Derivative equals to 0. Well, here derivative equals 0. I mean, f of c equals 0. That's the intermediate value theorem, not derivative. The function value. The function value is 0, right? Because root means x-intercept, means the y value is 0. So that's the intermediate value theorem. So we don't need a derivative at all. But let's see this let's use Rolle's theorem. So using intermediate value theorem, we can prove there's a root for this equation. And also we can use Rolle's theorem. So we need to find the function. So this is the function x cubed plus x minus 1 is the function we're talking about, and it's continuous. And let's suppose it has two roots. Suppose have two roots a and b, right? Then f of a, because it's roots, so f of a equals 0, f of b equals 0. That means f of a equals to f of b, right? And we know polynomial function is differentiable at every point, right? So we satisfy the first condition. First condition is satisfied because it's a polynomial degree 3 function. And second also is satisfied, is differentiable in any open interval. And the third condition is also satisfied, f of a, f of b. They're both roots, they're both equal to 0. So then let's say there must be a number c such that derivative equals to 0. So that means we must have x equals c. The C is in between A and B, and the derivative at the point is 0. Right? But then we take a derivative of the function. What's the derivative of this? So 3x squared plus 1. Well, we observe this. 3x squared plus 1 always positive and always greater than or equal to 1, at least 1 for all x value, because this is square. We have x squared term. Well, this is saying, the derivative function 3x squared plus 1 will never be 0, right? If we set up to 0, we won't be able to find any x to satisfy the equation. So this gives a contradiction, right? So this is saying the equation cannot have 2 real roots, which means can only have 1 real root. So by intermediate value theorem, we know there must be a root, 1 root. And then we see, because it's a cubic function can have 2 roots at the most. So this is for any polynomial function. If a polynomial function is degree n, it can have maximum n minus 1 roots. So this is a polynomial degree 3. Maximally, it can have 2 roots. So it can have 2 roots at maximum. But here we want to show this, when we set the function value equal to 0, it has exactly 1 real root. So by intermediate value theorem, we prove that there must be roots. But then we use the Rolle's theorem, there can only be 1 root. All right, that's how we use it. That's how we use it in applications for Rolle's root. Okay, but mainly the most popular one is the mean value theorem. Mean value theorem. We don't have to have the third condition here in the Rolle's. Rolle's, we have the third condition, f of a equals f of b. Mean value theorem is saying we don't need to have, we only need 2 conditions, the first 2 conditions in Rolle's theorem. So f is continuous in a closed interval, f is differentiable on the same open interval. Then there must be a number c, the c is in between of the interval, such that the derivative at c is the slope of the line passing f of a and f of b. So let's see the graph. Okay, we have this function. We have this function from a to b. Well, it's continuous, right? It's differentiable at the open one. And the f of a does not have to be f of b, but however, we can connect f of a and f of b. So we can connect those 2 points. And we can talk about the derivative of this line, right? Just f of b minus f of a divided by b minus a. That's the slope of this line. Mean value theorem is saying there must be a point C, and the derivative at the point C is the same as the slope of this line. Right? Basically saying those 2 lines are parallel. That's mean value theorem. Well, we can see this graph, figure 4, right? From A to B, we see 2 lines are parallel to this f of a, to this AB. So that's mean value theorem. Mean value theorem. We don't need f of a equals f of b. Let's see how we use this. Okay, let's see. To illustrate the mean value theorem with a specific function, let's consider f of x equals x cubed minus x, a equals 0, b equals 2. Since f is a polynomial, it's continuous and it's differentiable for all x. So it's certainly continuous on certain interval from 0 to 2. And differentiable on the open interval from 0 to 2. So therefore, by mean value theorem, there's a number c in the interval of 0 and 2 such that f derivative of c equals to f of 2 minus f of 0 divided by 2 minus 0. So what's f of 2? f of 2 equals to 2 cubed minus 2, which is 6. F of 0 equals 0 minus 0, which is 0. So one way, so f prime of c equals to 6 minus 0 divided by 2 minus 0, which is 3. Which is 3. So f of 2 is 6, f of 0 is 0. So 6 minus 0, that's 6. 6 divided by 2, so f prime of c equals to 3. Well, let's see. Then f prime of c equals 0. F prime of c equals to 3. So this equals 3. Equals to 3x squared minus 1. So that means 3x squared equals to 4. Right? So that's right here. So here, f prime of c equals to 3. Excuse me. So here, then we can write into this equation 3 equals to 3x squared, because we take a derivative of the function, right? Derivative of the function is 3x squared minus 1. Minus 1. Then we solve this equation. So we get x squared equals to 4 divided by 3. Right? X squared or c. We could just use c. Right? Could just use c. Because this is the f prime of c. So we could just think of this x as c. So c squared equals to 4 over 3. Then we square root both sides. So we get c equals to plus minus 2 divided by radical 3. So we see we have 2 such c. Two such c. But c must lie in 0, 2, because we limited. We're only working with the interval of 0 and 2. So we'll reject a negative value. Reject the negative 2 divided by radical 3. So have c equals 2 divided by radical 3. So you will see from the graph, right, the graph of the function x cubed minus x goes this way. And a is 0, b is 2, right? So a line passing these 2 points is this. By mean value theorem, there must be a value c. The tangent line, the slope of the tangent line is the same as the slope of this line passing these 2 points. All right, this is one example how we use this mean value theorem. Mean value theorem is very useful. Let's see example 4. Example 4 is saying if an object moves in a straight line with a position function f of t, then the average velocity between t equals to a and t equals to b is f of b minus f of a divided by b minus a, of course, right? So we can just write this as by f prime of c equals to, right? The mean value theorem, because observe the well, let's not see this yet. So this is true, right? Because the velocity equals to the slope of the tangent line. So this is using that. The velocity equals the slope of the tangent line. And what is the velocity? Velocity at c is f prime of c, right? So then we can write this equals to f prime of c. So the mean value theorem tells us there must be times c, t equals to c between a and b. The instantaneous velocity, f prime of c, is equal to the average velocity. Well, the average velocity is the slope of the tangent line. Is the slope of the line passing through this a f of a, b f of b, those 2 points. We call that average velocity. So let's see this conclusion. So in general, the mean value theorem can be interpreted as saying that there is a number at which the instantaneous rate of change is equal to the average rate of change, right? Equal to the average rate of change over the interval. What is the average rate of change? Right, from 0 to 2 in this case, the average rate of change is the slope of this line passing through these 2 points, equals to the instantaneous rate of this at this point C. Okay, let's see example 5. So suppose f of 0 equals -3 and the derivative of x always less than or equal to 5. So the derivative is at most 5 for all values of x. How large can f of 2 possibly be? So here we have 0, we're talking about 0 up to 2, right? Consider this. So one x value is 0, another x value is 2, so working with the interval from 0 to 2. And we're going to use the mean value theorem. Mean value theorem is saying, okay, in the interval 0 to 2 must be a c, a value c, and the derivative at the point, the instantaneous rate of the function at c equals to the average rate of the velocity from 0 to 2. So f of 2 minus f of 0 divided by 2 minus 0. So we solve for f of 2. F of 0 is given -3. Right? -3 we move to the other side, becomes +3. So f of 2 equals to 3 plus this term, 2 times this derivative. But this derivative is constrained with 5, at the most 5. So f of 0 equals f of 0 plus 2 times this, or equals to, this should be +3, isn't it? F of 2, f of 2 minus -3, so this becomes plus. When we move to the other side, that becomes negative, right? -3. So f of 0, which is -3 plus 2 times this. And this is constrained by 5. So we have -3 plus 2 times 5, or 2 times 5 is 10. So -3 plus 10 is 7. So f of 2 at the most 7. So the largest possible for f of 2 is 7. All right, so this is using the mean value theorem, right? Let's see, another theorem is derived by the mean value theorem. So if the derivative equals 0, well, this is kind of like going backwards, right? If the derivative equals 0, so that means f of b minus f of a divided by a minus b is 0, which means the slope of tangent line is 0, which means we imagine a horizontal line. So this is saying, say horizontal line. For all x in the interval, then f is constant on a and b. Well, this is a theorem, right? This is like you can think about the Rolle's theorem and the mean value theorem. Let's see this one. Okay, corollary. If a derivative of f equals the derivative of g for all x in the interval a to b, then the difference of these two functions is constant on AB. That is f of x equals g of x plus c, where c is a constant, right? Sometimes this is useful, but for this class, this is not too useful. All right, now let's use the mean value theorem to do some exercise. Let's see, 1 to 4. Verify the function satisfies the 3 hypotheses of Rolle's theorem on a given interval. Then find all numbers c that satisfy the conclusion of Rolle's theorem. Let's try to use mean value theorem. Try to use let x equals this. It shows that f of -1 equals f1, but there is no number in C. Then why does this not consider? Okay, let's try this 4. Let's try to use mean value theorem for this 4. So let's try this 4. Use mean value theorem to find the number C, all right? Okay, let's try 9, 10, 11, 12. Okay, maybe we need 2 more people to show the work. Okay, maybe 1 more person. All right, let's start. So Elsa, we start with you.
Professor?
Yeah.
Yeah, I'm having a problem. So can you 10? So I'll get back to. I just need 2 minutes.
Sure. Julie, are you ready?
Yep, let me just pull up the document here.
Okay.
Can everyone see?
Yeah.
Okay, so the question is to use the mean value theorem to prove that this exists. And so we're given the function f of x equals x to the third minus 3x plus 2, and the interval negative 2 to 2. And so what you do is you you substitute into the equation f of b minus f of a over b minus a. And so you also take the derivative of the first function of f of x, because f of prime of c, that's the same thing as f prime of x. And so you get 3 of x squared minus 3 on one side, and then you get equals f of 2 minus f of negative 2 over 2 minus negative 2. So you substitute the 2 into the equations. So you get 2 to the third minus 3 times 2 plus 2 minus negative 2 to the third minus 3 minus times negative 2 plus 2. And then that's all over 4. And then you simplify it further and you get 3x squared minus 3 equals 8 minus x plus 2 minus negative 8 plus 6 plus 2. And that simplifies to 4 minus 0 over 4, which is the same thing as 1. And so 3c squared minus 3 equals 1. And then you add the plus 3 to take it off from one side. Then to the other side, and then you get 3c squared equals 4. And then you divide it by 3 to get rid of the 3 on the c side. And then you, oh, sorry, I don't know what happened.
It looks great.
Let me see if I could find it here. Okay. Okay, then you take the square root of it, so you can get rid of the squared on the c side, and you get c equals plus or minus square root of 4 over 3.
Yeah, we know square root of 4, right?
Sorry?
We know square root of 4. We can simplify square root of 4, right?
Yeah.
Right. So basically, we like to rationalize the denominator.
Oh,
So
okay,
maybe,
okay.
yeah. Okay, great. Good job. Anybody has any question? Okay, thank you, Julie. So let's see,
Thank
next
you.
one. Thank you. All right.
Yes, Professor?
Yeah, go ahead.
Yeah, I'm ready.
Yeah, go ahead.
So basically, we're going to take the slope of the function, which is f of 2 minus f of 0 over 2 minus 0. And as you could see, I found f of 2 and f of 0. F of 2 is 3 and f of 0 is 1. And then when we do 3 minus 1 and 2 minus 0 over 2 minus 0, we get 1. And then we find the derivative of the function, which is 4x minus 3. And then we equal it to the slope, which we get x equals 1, and which means the c is equal to 1.
Yeah, great. Yeah, that's how we apply mean value theorem. All right, thank you, Arisa. Next one. Chloe.
Hi, yes. 1 second, let me just turn on.
Okay.
Did the other person just upload an image?
Yeah.
Can I do it that way? Okay.
Yeah, you could share, right, your file. It'd be wonderful.
Okay, great. Sorry. You know what? I think it might just. I'll just turn on my camera because it'll take too long for me to do the other way. So. Sorry, 1 sec.
So we need one more person to share. Like 11.
I'm doing 12 though, right? So you're
I know,
speaking to
you're
someone
doing
else?
top. So you
Okay.
can someone to, right, to do
Okay.
it.
So I just. How did. Sorry, how did that person upload the image on? Oh wait, I see shared content, share files, and then.
Applications / screen.
Okay, I see. Let's see. Add files. Okay.
Don't do add files. Do the second one. Share your applications / screen. So you open your file.
Oh, okay.
Yeah, you open your file on computer.
Share application screen. Okay. So
Then
not share file, right?
don't share file, right? Then choose the
Okay.
middle one after.
Okay. Right.
I would need one more person to show 11. Anybody like to show your 11? Yeah, except Noella. Anybody else? I see Alexandra is here. Emily is here. Hillary. Hillary, do you like to share 11? Julia and Ryan. Stanley, Tanzania, and Van. Because you need to share to earn your presentation credits. Okay.
Okay, so I'm sharing now. Can you see it?
Yes.
Is it? Yeah, this is a mess, but does it help if I zoom? Oh, whoa. Can you see it zoomed in, or does it
Yeah,
not?
we can zoom ourselves. I can zoom. Yeah, go ahead.
Okay. Sorry about this. So for the function f of x, 1 over x, on the interval 1, 3, I use the mean value theorem to plug in for the function 1 over x. So therefore you see that f of 3 is 1 over 3. F of 1 is, I plugged that in and I got 1. So I got the derivative of the constant, and then I plugged in for that. And then you see there, like I plugged into the value theorem, 1 over 3 on the top minus 1, and then 3 minus 1 at the bottom. And then I simplified that to get, I carried it on the negative sign for 1 over the constant squared equals to negative 1, negative 1 over the constant squared equals negative 1 over 3. And I simplified that. I took over the square root. And I didn't know if you wanted me to simplify more after that, like to decimal numbers, but
No, the root 3 is perfect.
okay.
But if you solve C squared, how many answers you have?
If I solve, sorry?
When you solve C squared, right? How many answers you have? You only have square root of 3.
Did you say?
Okay, how did you get it from it? Okay, look at your last step is C equals square root of 3, right?
Yeah.
Can you explain how did you get this answer?
From square, I took the square root sign from the 1 over c squared.
You take the square root sign. Can you take square root of a negative number?
No, but it can't. The negative cancels out because I divide.
Okay.
Because I take the negative. Yeah, from the other side.
Okay. So right. So then you have 1 over c squared equals 1 over 3, right?
Yes.
All right. So how did you solve from there to get c equals to radical 3?
I take the square root. Wait. Can you repeat that last question?
Because you didn't show me how did you get. You didn't show me how did you get your answer c equals radical 3. You skipped some steps, right? I just want you to tell me what are those steps you skipped. Excuse me. Hello.
Hello. Yes. Yeah. I'm trying to understand your question because you said you didn't repeat your question from before. So you said after.
Okay. You see your result is c equals to radical 3, right?
Yes.
Okay. So how did you get c equals radical 3 from your previous step, negative 1 over c squared equals negative 1 over 3? You skipped some steps, right? I just want you to explain those steps you skipped.
Okay. Let me just look back on my work because I rewrote it. So from negative 1 over 6 squared. It's 1 over. Okay,
Did you do this yourself?
yeah, but like I'm looking back on my work now and now I'm getting I'm getting 1 over 36. So, 1 second. Yeah, because like I'm getting like 1 over 9 squared. No, I didn't get 6 squared. I got 9. I took the square root from the 9, not from 6. So
No, I don't think you know what you're talking about. I won't be able to give you credit for this.
okay.
Right. So let me explain for you. You know, someone did. So here, what's going on? You have negative 1 over c squared equals negative 1 over 3. But first, let's go back. So derivative of f, so function equals 1 over x, right?
Mhm.
You know, this step, you know, f prime of c equals negative 1 over c squared. Do you know how do you go from here, get here? From f of x equals 1 over x to get f prime of c equals to negative 1 over c squared.
From f prime of c to get
Right, so this step, okay, how do you get f
prime.
prime of c equals to 1 over c squared?
I plugged in the 3, so I actually didn't get like 1 over 6 squared. I got 9 squared instead. So that's why I think I did something wrong there.
Chloe, I don't think you did this work. Someone else did this work for you. But doesn't matter. Even someone else did this work for you, you should understand what's going on in step. It's good to have a tutor, but it's not only copying the work. It's about to understand what's going on in each step. All right. So I won't be able to explain to you everything here, but this tutor is pretty good. So ask this tutor help you. Not this way, you know, it's not good help. A good help is to make sure you understand what's going on with each step. All right.
Mm-hmm.
Okay. Anybody else wants to show 11 and 12?
Professor?
Yeah.
I don't know how to stop sharing. Can you take me off presenter? Because it's like, I don't know how to.
Let me see. I don't know how to do that actually. Okay, Vaughn is doing 11. Maybe if Vaughn then
Share content.
you see you have a circle. Do you see this circle and with a square?
Oh, gotcha. Gotcha. Thank you.
Can you see it?
Yeah.
So we were given the function f of x equals the cube root of x, and I try to find f of 0, which is 0, and f of 1 equals the cube root of 1 equals 1, and you substitute those numbers into f prime of c, which is 1 minus 0 over 1 equals 1, and you find the derivative of f of x, which is 1 over 3x to the 1/3 power, and you equal it to 1. So I multiplied 3x to the 1/3 on both sides to cancel out 3x to the 1/3 on the bottom, and I got 1 equals 3x to the 1/3, and I divided both sides by 3, and I got x to the 1 equals 1 over 3, and I cube rooted to find x equals cube root of 1 over 3, or c equals cube root of 1 over 3.
Okay, Vaughn, let me ask you this question.
Yeah.
So your f of x is the cubic root of x. Excuse me.
Yes.
Tell me, how do you get derivative function is 1 over 3 x raised by 1/3.
So cube root of x could also be rewritten as x to the 1/3 power, and you use the power rule, so it would be 1/3 x, and for the power rule, you do 1/3 minus 1, which is negative. Oh, wait. Oh, it's supposed to be 1 over 3x to the 1 over 3x to the 2 over 3. I see a mistake now.
That's right. Good. You correct yourself. 2 over 3. Right
Yeah.
now, how do you change your answer?
So it would be 1 equals 3x to the 2 over 3. So it would be x to the 2/3 equals 1 over 3. So it would be cube root of 1/3 squared. That's right?
Yeah.
Okay. Thank you.
So all those become 2's. This become 2.
2 over 3.
Right? Is it 2 or 2 over 3? So your answer in the end, what should be your answer?
Cube root of 1 over 6.
Over 6. Go through this step. You see, you have a cube. You have 3 x raised by. Basically, you have x raised by 2 over 3 equals to 1/3, right? Then you cube a root on both sides. You have x squared equals to this. Does it make sense?
Yes.
So
Okay.
now, right, you have x squared. So when you square root, what do you get?
Square root.
How do you square root a number?
You would multiply the 3 and the 2 together.
That's right. You multiply the index. It's called the index.
The index.
Cube root 3 is called the index. Because you square root, you cube root. That's same to say 6 root plus minus 6 root of 1/3. So which interval you're working with?
0,
0 to
1.
So what do you do with your answer?
Do I equal to the 0 and the 1?
What do you mean you're equal to? So what is the mean value theorem?
The mean value is 0. Trying to find the point in between the interval.
Okay. So you have two C's, right? Which one is in between of the interval?
Oh, positive one.
The positive one. So what do you do with the negative one?
You don't use it because it's not in the interval.
Exactly. So you see, because the negative value is not in the interval, you just take the positive one. All right. Okay, good. So you are able to correct your own mistake. All right. So
Thank you.
Thank you. This is 11. All right. Anyone wants to show 12?
Professor?
Yeah.
If no one wants to, I'll show 12.
Okay. Yeah, go ahead. Let's see. Emily, Jason, Julia, Karen, Ryan, Sophia, Stanley, Tanzania. None of you wants to show 11? All right. Ursa, go ahead, Ursa.
Can you see it, Professor?
Not yet. Yes.
Now?
Yes. Yeah.
So basically, we're going to take the derivative of the function 1 over x over the using the reciprocal rule, which is negative f over f squared. And you get 1 over c squared. And then you're going to, so basically, you're going to take the slope, and f of 1 is 1, and f of 3 is 1 over 3. And using the slope formula, see f of 3 minus f of 1 over 3 minus 1, you get negative 1 over 3. And then you make the a derivative of the function and the equals to each other. And then you're going to cross multiply, basically, and then you're going to get radical 3.
So when you square root, how many values you get for c?
Oh, it's going to be plus and minus. Sorry.
Yeah, it's gonna be plus minus. But only you only take the positive value because
It's in the interval 1 and 3.
that's right. Also the second line, right? The second line you wrote f prime of x equals to negative 1 over c squared. Maybe you mean f prime of c.
Oh, yeah, exactly. I'm sorry.
Yeah. Okay. All right. Good. All right. Thank you, Ursa.
Yes, thank you.
Okay. So we have 11 minutes. Let's talk a little bit more about. So this mean value theorem, very easy to use. Okay, so the rest of 10 minutes, I'm going to talk a little bit about the derivatives and the shapes of graphs. So derivatives tell us, the derivative of a function tells us something about the original function. So let's see what does it tells us. So basically here, increasing or decreasing. Okay. If the value of the derivative is greater than 0 or positive in the interval, that means f, the original function, is increasing on the interval. See, this shouldn't be difficult to understand, right? So this is saying the slope of the tangent at x is positive, right? If it's positive, we know the slope goes through the first quadrant and the third quadrant. Oops. So let's see here, right? Think about the point here. The line goes through the first quadrant and the third quadrant. The slope being positive. Right? If we can think about another point. When the function increases, from a to b in this interval, right? In this interval, the function increases. How can we tell increases? When we make an arrow from left to right, it goes upward. That means the function increases. That means when x value increases, x value goes bigger, y value also goes bigger. Right? Both variables, value of both variables increases. So x value and y value and the function value go hand in hand. So the function increases. The slope you see from a to b, the derivative at any point in this interval is positive. In contrast, from b to c, the function decreases, right? The arrow goes down, the arrow goes downward. This means when the x value increases, the y value decreases, right? So x value and f of x value does not go to the same direction. So the function decreases. And we can see the slope at any point of the tangent line is negative. It's negative. We have negative slope of the tangent line. So decrease. Again, from C to C, the derivative at any point in the interval from C to D is positive. The function increase, the original function increases. Okay, so the derivative, the value of the derivative of the function tells us if the function increases or decreases in a certain interval. Let's see example 1. We want to find where the function, this fourth degree of polynomial, is increasing and decreasing. So we take the derivative, then we get a cubic, polynomial degree 3, right? The original function is polynomial degree 4. The first derivative is degree one degree lower. We can factor this, right? We can factor this. Then we set this one to be 0. Then we set this one to be 0. We solve for x, solve for the critical numbers. Right? We take the derivative, we set to be 0. Why we want to do that? Look at this. From a to b, function increases. After b, so from b to c decreases. Then from c to d increases. So b here is a turning point. C here is a turning point. We call this critical numbers, right? So B, f of B, C, f of C are critical numbers. So first we want to find those critical numbers. So we take the derivative of a function, we set to 0, we want to find critical number. Find critical numbers, right? Then we solve this in a factor form. We use 0 property, where this is saying x equals 0, x equals 2, x equals to -1. So we have 3 critical numbers. X equals 0, 2, and -1. Have these 3 critical numbers. If you see the graph right here, right? We have, is this one? No, this is a derivative. Okay, anyway, let's not look at this. So we have these 3 critical numbers. Oh, actually, yes. You see this one, and this one, right? We have local minimum, local maximum, and local minimum. So we have these 3 critical numbers. And then we want to, so 3 critical numbers give us 4 intervals. Let me move this one here. So we have 3 critical numbers. And 3 critical numbers give us 4 intervals. So from -infinity up to -1, the smallest number. Then -1 up to 0, another interval. Then from 0 to 2, third interval. Then from 2 up to positive infinity. I have these 4 intervals. You see here, from this point down, right, we have this interval from -infinity up to this point, up to this critical number, -1, one interval. Then from -1 up to 0, another interval. Then from 0 up to 2, another interval. Then from 2 up to positive infinity, another interval. So 3 critical numbers give us 4 intervals. Give us 4 intervals. So then what do? Then we just choose a number in this interval. So from -infinity up to -1, or we could use this notation to represent right here. Right? So the first interval we can use x less than -1. That means from -1 up to -infinity. So one interval. Then from -1 to 0, second interval. From 0 to 2, third interval. Then from 2 to positive infinity, fourth interval. So what do? We just choose a value in this interval. Let's see. -1 up to -infinity. Maybe we choose 2. right? We choose -2 in this interval, -2 in this interval. So for this, so -1 up to 0, maybe we choose -½ We can choose -½ From 0 to 2, we may choose 1. Just choose any convenient number in the interval. From 2 up to infinity, maybe we choose 3. Right? So in each interval, we choose a convenient number. Then we evaluate the function, the derivative function. So we want to evaluate f prime of -2. We want to see if f prime of -2 is positive or negative. All we have to figure out if it's positive or negative, right? If it's positive, we know the original function increases. If it's negative, the original function decreases. So we choose a value in the interval, then we evaluate. We basically choose a representative, right? In this interval, we choose a representative. -2, -3, -5, doesn't matter, as long as it's in this interval. Right, so we want to evaluate this. How do we evaluate this? We go back to this form, the factor form. So 12 times -2, or they wrote over here, so 3 factors, right? 12 times -2 will be negative value. Then f of -2 minus 2, the second factor, -2 minus 2 will be negative value. Then -2 plus 1 will be negative value. So 3 factors, right? We have negative times negative times negative, it stays negative. So the derivative in this interval is negative, right? So less than 0. So similarly, we choose -½ in the second interval from -1 to 0. Well, -½ times 12 is negative. -½ minus 2 negative. -½ plus 1 positive. Negative times negative, positive times positive, positive. So derivative now is positive. If it's positive, it increases in the interval. If it's negative, decreases in the interval. Similarly, for for this in the interval of 0 to 2, we can choose a 1, right? 12 times 1 positive, 1 minus 2 negative, 1 plus 1 positive. You multiply, get negative. So that means our original function decreases in this interval. Then choose 3 in the last interval, 12 times 3 positive, 3 minus 2 positive, 3 plus 1 positive. So the function in the interval increases. All right, so this is how we use derivative, the value of derivative, to see if the original function increases or decreases. Okay, I'm going to leave you some work for this. Find the intervals. Okay, so let's do 1 up to 5. All right, so this is for next class. We want to have the, let's see, 7 to 8, find the local minimum or maximum value using the first, second. No, we're going to do this later. So try to do 1 up to, oh, okay, actually this 6. So 1 up to 6 for next class. Okay, find the intervals of the function increases or decreases. All right, any questions? Okay, if no question, I see you tomorrow actually. Tomorrow is Thursday. So I have 2 days in a row.
Professor?
Yeah. Yes.
Did you take attendance? I was a little bit late.
I'm sorry, I couldn't hear you. Ursa, what did you see?
I was like, did you take attendance?
Oh, yes, I did. Yeah. All right. See you tomorrow.